So instead of using rectangles as we did before, we're going to use trapezoids in this one. Now, this here is notation that we haven't seen in this class. Some of you have. All this just means for us is the area under the curve. So area under f of x. So we're going to do the same thing. We're going to find an approximation. But we're going to use trapezoids. So recall the area of a trapezoid is 1/2 sum of the bases times the height. And when we're looking at these, our bases are our heights here. So really this here are our f of x's. So when we're looking at just this subinterval here, so we have this trapezoid here from x going 0 to 2, where that base is 5, that base is 9. And our height then is 2. So our height really is our delta x. Okay? So when we're finding the trapezoidal approximation, I'll go area sub t for trapezoid. So 1/2. We're gonna get the area of this first trapezoid. So sum of the bases are 5 plus 9, and with a height between those two bases of 2, 0 to 2. Do the same thing from here. 1/2 sum of the bases are the f of x, so 9 plus 14 times our delta x, which is our height of the trapezoid, 2. 1/2 sum of the bases, again our bases are our function values, times our delta x, distance between the bases, 1/2 sum of the bases, times delta x is our height. And then the last trapezoid. 1/2 sum of the bases times delta x, which is our height. Okay. Again, notice when we say 5 subintervals, there should be 5, 1, 2, 3, 4, 5 trapezoids. And so the approximation of that turns out to be 187.5. Again, calculation not too terribly concerned about. Okay, same thing. So let's find the area under this curve, area under f of x, using 4 subintervals. So there'll be 4 trapezoids from 3 to 4, 4 to 5, 5 to 6, 6 to 7. Now I'm going to add in that one other step beforehand. So the step of using function notation. So it's still trapezoids, so it's still 1/2. The bases will be f of 3 plus f of 4 times our delta x, which is our height. Then the second one. So what is f of 4 and f of 5 are our bases times our height. 1/2 times sum of the bases, so f of 5 plus f of 6 times delta x, which is our height of the trapezoid, and finally the last one between 6 and 7. Now there is a method to this madness here, which, gotta make sure I put that parentheses there. So sum of the bases times the height. So now I can go in, f of 3 is 2, f of 4 is 5, I'm going to ignore the times 1, 5 plus 8 times 1, 8 and 12, times 1, 12 and 19 times 1. And so our trapezoidal approximation turns out to be 14.2. That don't look right. That's not right. For some reason I did 1/5 instead of 1/2. Thinking 0.5 instead of 35 and a half. Or 71/2. Okay. Other big nice thing about these trapezoids. Now notice, if we have something really irregular like this, if we would use rectangles, we would either use a rectangle like this, and then like this. You see, there would be a lot more error in these. We don't want to do that. If we use trapezoids, though, notice, in this one here, there may be a few more, a little bit more error, but you see how here, there's a lot less of the area that's either uncovered, not covered, or extra. And in this case, our height, distance between the bases, is right here. Again, why do we know that? Is because the height is a distance. So each measure is 10 feet apart, and we measure on perpendiculars. So, trapezoidal approximation. 1/2 sum of the bases. So the bases are here, times the height, the distance between them. Next trapezoid. Bases are 105 and 110. Distance between. Third trapezoid, between 110 and 120 length. Are your legs? Sorry, your bases. Times the distance between is your height. And then the last trapezoid, 120 to 140. And the distance between. So the trapezoidal approximation, so the surface area of that lake is about 3,675 square feet. If we knew other things, we could do other things with this. So that's how we do. That's one of the options. Okay, so let's take a look at, we do have a rule, the trapezoidal rule. And wait, what is going on with this? Okay, I know this looks a little strange writing it, but let's go back to that second example. This is why I wrote it out. Notice. So, half times the height. There's your half, there's your height. But notice how f of 4 is used twice. F of 5 twice. F of 6 is used twice. And the end pieces, the 3 and the 7, f of 3, f of 7, are only used one time. So that's where this rule comes from, is that here is your height, subintervals, or our delta x, over 2, so half of that. Here's your first piece, your like beginning. Here's your end, and here are all the different legs in between, all the different bases. I keep saying legs. All the different bases in between. Now, big key in trapezoidal rule is right here. If they have uniform length. If those subintervals are the same length, then you can use it. If you can't, like the first example, you can't do it. Don't do it. But as long as we can, no problem. As long as we have uniform length or equal subintervals. So how do we start off something like this? Again, what's the area of this function from 1 to 3? Well, we're going to start off the same way. So what's delta x? 3 minus 1 over 4. And I'm going to write my little x-axis starting from 1 and counting up by half. So 3 halves, 2, 5 halves, 3. You can think 6 halves too. So there are what I'm going to do. So here's the ends, 1, f of 1 and f of 3. So trapezoidal rule, red for rule, 1/2 times the height. Now I don't do it h over 2. I like seeing this way better. H over 2 works out great for a formula. So this is the 1/2, this is our h. So now let's fill in the legs. So f of 1. The endpoint only, that we don't know what f is, so we'll use 1 as 1 squared plus 1. Plugging 1 into right there. Then 2, when we plug in 3 over 2. Again, because this is used in 3 halves, is used the trapezoid on the left and on the right. 2 when we plug in 2. With this base, again, left trapezoid, right trapezoid, we're using it twice. 2 when we plug in 5 halves. That base is used again twice, left, right, and then the 3 is only used in one trapezoid, the one on the left. So again, recap. Half times the height, the delta x. So this is your first base, this is your last base. Those are only used once because they're only used to the one side of it. The ones in the middle are used both sides. That's why there's 2. And so we just plug all that in to our brain, our calculator, whichever way, our calculator brain, we end up with, I did a calculator, that's why I get 10.75. It would end up being 43 over 4 when we multiply out. So all of this inside is going to turn out to be 43 times a fourth. Does it matter when we get trig? Nope. So it's same thing, get our choice. Pi minus 0 over 6. So start at 0, because that's where we start. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then our 6th one should be where we end. Look, it is. Woohoo! Again, we could use the rule. So 1/2 from the formula. The height, the delta x. Now plug in each one. So cosine squared of 0. The end is used once. 2 cosine squared of pi over 6. 2 cosine squared of pi over 3 plus 2 cosine squared of pi over 2. 2 cosine squared of 2 pi over 3 plus 2 cosine squared of 5 pi over 6, and finally cosine of pi, cosine squared of pi. Now a couple nice things about, you can go ahead and plug it all in, and we end up getting pi over